Let's do one numerical on Kohonen Self-Organizing Map, right? The weights, what weights the inputs and the cluster nodes are having, how they are connected, that we have shown here. This is the weight matrix where is given to us. And what we have to calculate in this numerical Kohonen Self-Organizing Map, we have to calculate the Euclidean distances of all these clusters from these units, right? This is one thing we have to find out. And the input vector which is given to us here is 0.3 and 0.4, right? So with respect to 0.3 and 0.4, we have to find out the Euclidean distances. That means the Euclidean distances that we will get here will be D1, D2, D3, D4, D5, right? So this is what we have to find out in the part A. In part B, we have to find out the new weights, right? What will be the new weight? So the distance, which is the minimum distance we have, that will be the winning node for us, winning state for us. And with respect to that, we will update the weights of that CG, right? Of that particular cluster. The third part is saying that we have to find out the CJ minus 1 and CJ plus 1, right? So that we will also. So let's start from the part 1 now, how we are going to solve this numerical, which is very important in terms of examination, right? So the initial wave matrix, which is given to us, is this, right? 0.2, 0.3, 0.6, and this, right? So this is for the input U1, right? This one is for unit input U1 with respect to all these 5 clusters, and this is for the input U2 for all these 5 outputs, for all these 5 clusters, right? So this we have with us. Now, after initializing the weight matrix with respect to the nodes that we have with us, we have to start the training part, right? We have to follow the training algorithm that we have already discussed in the class, in the previous class, that what is the Kohonen Self-Organizing Map, right? So, we have to begin with the training, and for the input vector 0.3 and 0.4, we have to perform few steps, right? What are those steps? Let's do that. For every input and output, we have to find out the Euclidean distance, right? So for the Euclidean distance, this is the formula. dj is equal to the summation of weight wij minus xi whole square. So dj is what here? dj here is d1, d2, d3, d4, d5, because we have here 5 clusters as we have shown, as it is shown in the figure. We have here 5 clusters or 5 outputs, right? So we need to find out the d1, d2, d3, d4, d5, right? For all with respect to all the clusters that we have with us. Then after that, what are the inputs we have? Regarding the inputs, we have 2 inputs here. We have a U1, U2. These are the 2 inputs we have with us, right? Now, after talking about inputs, what we have with us is, these are the inputs we have, X1, X2. So we have to take the summation of the differences of the weight and the unit X1, and it will be like this, right? So this will be, these are the values of D1, D2, D3, D4, D5, right? So this is the way how we are calculating the Euclidean distance. This is the first step. What is the second one? The second one is after finding out the D1 using these formulas, what next we have is the input vector is closest to the output node 1. D1 is minimum. So J is equal to 1. Now, after calculating the Euclidean distance, what we have is this. We find it, we notice this thing that 0.02 is the minimum, right? 0.02 is the minimum one. So it is the winning one, right? So as per the algorithm, when we calculate the distance, we have to find out this thing that which one is the minimum one, right? So the minimum one is the D1 with us. So when we are finding out that this is the minimum, so J is equal to 1, for J is equal to 1, it will become the closest for the node 1. So D1 is the minimum for that. Now for the second, what the next step for us to do? Next step is this: we have to update the weights as per the second part is saying. Second part is saying we have to find out the weights, right? So we have calculated the DJs, that is the Euclidean distances. We got that which one is the closest one. So the next thing is we have to update the weights. So regarding the updation of the weights, we know their formula, that Wij new is equal to Wij old plus alpha xi minus Wij old. This is the formula for calculating the new weight, right? So this is the formula for calculating the new weight. We have substituted the values of the weights and the learning rate. And this is the way how we calculate the weight. And then W21 new is equal to W21 old plus alpha x2 minus W2 old, right? This is the way how we are calculating W11 and W21, right? Just applying the formula and these values, right? So with respect to D1, or with respect to first cluster, we have updated the weights, right? So the new cluster after updation of these weights, these are to 0.23 and 0.33, the new matrix of the weights will be like this, right? So these are the weights for the cluster 1 are updated here, like, fine. Now the third part. In the third part, what they're saying find out the weight for Cj minus 1 and Cj plus 1. Now, we know that the value of J varies from 1 to 5. So J minus 1 means 1 minus 1. It's C0. C0 is nowhere lying, right? We don't have C0 in our network. So we cannot calculate, we cannot update the weight for C0. But in spite of this, we have Cj plus 1 also. And for that, if we say J is equal to 1, it means for that we have to update the weights for C2, right? So for C2, we are going to apply the same formula for updating the weights. And how we will be doing? We will be doing like this. C2 will be like weight updation for the unit 2 means it will be W212 and W22, right? So here we are updating the weights from input 1 and input 2 for the cluster second, right? So for the cluster second, the 0.51 will be the first weight, and 0.47 will be the second weight, right? So the updated matrix, weight matrix for this will be, this is for the cluster 1 and this is for the cluster 2. And the rest we have not yet touched because it's not being asked in the numerical, right? So this is one of the very important numerical. How we have to do is this, right?